Oh.
Watch that, so bad.
All right.
All right, Brecken and Gavin, that was their attempt to say all right, like I do in unison, but they couldn't do it. Page 149 in your textbooks. You had 8 problems to do for homework, 8 inequalities to solve. Page 149 is where we're going to start, though. You had the review numbers 10, 12, and 13. And number 10 at the bottom of page 149, pretty straightforward. At an x squared, positive 9x is greater than negative 14. I should also mention, by the way, Gavin and Brecken, this is red and green day, so I didn't lose all fashion sense. This is in the spirit of the day. Mm-hmm. You should see Genesis. Actually, Genesis looks fantastic, but Brandon, on the other hand,
looks a little trashy.
Anyway, so we have a quadratic inequality here, and Abby with the red hair and the green shirt from Southland Christian Camp. What do we need to do here?
Move the 14 over as positive 14.
And that'll have it greater than
0.
All right.
And then you can factor into x plus 7 and x plus 2. And then you set them both equal to 0. So x equals negative 7 and negative 2.
But these aren't actually my answers, Abby. They are
critical points.
Critical points on the number line. They're going to separate the number line into 3 different sections. So if here's 0, open dots or closed dots here?
Open.
Open dot. So an open dot at negative 2 and then another open dot at negative 7. So my 3 ranges here, let's go to Brandon now, are
parentheses, negative infinity, comma, negative 7, parentheses, negative 7, comma, negative 2, parentheses, negative 2, comma, infinity, parentheses.
Good, and we need to pick a test value from each of those ranges here. And Brandon, what did you test for the negative infinity to negative 7 range?
Negative 7.
And did it work?
Yes.
All right. Yep. All right. So this one checks out. What about what did you use between negative 7 and negative 2? Negative 3. And did that one work? No. All right. And then something that was between negative 2 and infinity?
0.
0, which probably is the first one you tried, right? And did 0 check out?
Yes.
Yes. So your answer should be negative infinity, negative 7, and negative 2 infinity. How many had this for number 10? All right. Questions, ladies? All right, we good? Now, all right, number 12, we had a similar problem. X squared negative 21x is less than negative 108. And Maddie, start us off on this one.
You move the negative 108 over as positive 108.
All right. That's a 1.
And you factor in 9, x negative 9 and x negative 12. And then you set it equal to 0, and you get x equals 9 and 12.
All right, and again, those are my 2 separate points. Let's see if we can do it without the number line this time, Maddie. If 9 and 12 are my separator points, what are my 3 ranges?
Negative infinity to 9, and then, parentheses, and then parentheses, 9, comma 12, parentheses, and then 12 to 10.
And probably the first number we love to test is 0, which would fall into which of the 3 ranges? The very first one. Does 0 check out?
Yes.
0 is less than negative 108?
No.
No, it doesn't check out. All right, so we're going to rule out that first. Okay, something between 9 and 12?
10.
10. And when you try to 10, does that check out?
No. Yeah.
Well, you square the 10, or 10, that's 100. And then the 10 times the negative 21 is negative 210.
Oh, yeah.
And that's negative 110, which is smaller by a little bit than negative 108, which doesn't have any cool sounds in it. And so this one does check out. So we're not expecting the last range to work, but what's a number we could try from the final range?
13.
13? And when we square 13?
169.
And then 13 times negative 21 is some big negative number, or technically some small negative number.
273.
Negative 273. And that comes out to
Negative 104.
Negative 104, which is not less than negative 108, so it doesn't check. And there's our only answer. How many had that for number 12? All right, questions on number 12. All right, number 13. We have an x to the 4th. Positive 6x cubed, negative 27x squared is less than or equal to 0. And I'm not sure how Maddie ended up doing the whole problem. I'm supposed to split that between Maddie and Audrey, but here we go. Audrey, start us off on the next one.
You take out an x squared. So you get x squared plus 6x negative 27. Then you can split that into x plus 9, x minus 3. And then you get x equals 0, negative 9, and 3.
Is it negative 3 or positive 3?
Positive.
For some reason I thought I heard a negative. So technically there's a 0 and another 0 because there's two zeros from the same thing. Small little detail here. So on the number line, we've got the negative 9 way down here, 0 and 3, my separator points. My first range here, Audrey, goes from...
Negative infinity to negative 9.
And we're going to use the bracket now on the numbers because of the or equal to. The next range is going to run, of course, from negative 9 to 0, but the next range is just 0, from 0 to 0. Since two separator points are technically zeros, the next range,
0 to 3.
and then the final range.
3 to infinity.
And so we can test to 0. If we plug in zeros everywhere, Genesis, they all turn into zeros. Is 0 less than or equal to 0? Yes. And we knew with the brackets here that it was going to work. If there had been parentheses, of course, there's no way it could have worked. The next test value we might try is, Genesis?
Between the negative 3 and the negative 9.
I could try that, but I'd rather try something else.
Also 3 and the infinity.
Okay, what's the number between 3 and infinity?
4.
4. To me, seems like an easier number to try. Still pretty obnoxious because we have to raise it to the 4th.
256.
Then we have to cube it and add 6, or multiply that by 6 rather.
380.
Then we're going to square it and multiply by negative 27. Which I don't know what that is. She does.
Negative 432.
All right, is this big positive plus this big positive minus this really big negative going to end up smaller than a 0? No, it's going to be positive, so we know this doesn't work. And this one does work. What's the next number we might try?
2.
2? So we go with 1. All right, so we raise 2 to the 4th.
Oh, 16.
16. 2 cubed times the 6.
48.
And then 2 squared times at negative 27.
Negative 108.
And does that come out less than or equal to 0?
Less.
Yes. Okay, so that comes out negative. So this range works. We already said this one works. I'm kind of feeling like the inners are going to work and the outers won't. Is kind of the vibe I'm getting here. Let's try something between 0 and negative 9.
Negative 1.
Thank you. Negative 1. And we raise negative 1 to the 4th. It just becomes
Negative 1.
even power.
1.
Positive 1. Then we cube the negative 1
Negative 1.
times 6.
Negative 6.
Then we square the negative 1
1.
times negative 27.
Negative 27.
Is that less than or equal to 0? Definitely. And so at this point, I've got all three of these inner ranges working. I'm just going to gamble the last range doesn't work. But anyone, how could I rewrite my answer rather than writing 3 separate ranges because I'm lazy? Anyone?
Right.
Good. Negative 9 to 3 in brackets because all of those points work anyway. There's no reason to list them separately. How many had that or had all three of those little ranges listed out? Anyone think to do it all as one? All right, just thought I'd ask. All right, questions on the 10, 12, 13 at the bottom of page 149. Yes, ma'am.
For problems like that on a test, would we need to write the 2 zeros for critical points when we write our critical points?
Well, as long as you remember there are 2 of them. Again, if this was an x cubed squared first, then you'd only pull out a single x, so it'd only give you a single 0, right? So at that point, this isn't even a range. 0 isn't its own range, which in this case didn't matter anyway, right? But in some cases, we worked a problem yesterday where it was like this bottom range, and then the 0 worked. It was really weird how that played out. So there are times that the 0 may work separately of the other ranges around it. Here it wouldn't have mattered necessarily, but again, just an x just equals a single 0. An x squared would be 2 zeros. Technically, an x cubed. I'm going to try to do 3 zeros, but anyway, 0 to 0, and then another 0 to 0 if one works out. Anyway, it's getting more into theory at that point. Questions on this? Hopefully I didn't confuse anyone with that. Brecken's like, me.
I didn't pay attention.
Sorry, Brecken. And Brandon just checked out. All right. Page 151, top of the page. You just did number 19 on this page. And not a quadratic at all, but higher power, like the last one. The last one was higher power. It had 4 critical points. But it ended up in quadratic form, so we kind of lumped in with the others. We've got an x cubed plus x squared minus 9x minus 9 is greater than or equal to 0. And Michael, what do I need to do with this one?
You need to group it.
Yes. How many factored by grouping? How many did P over Q? All right, either one works. But as I'm looking again, I always kind of lock in on the last set and see, is there anything easy to use there? And there is. I can pull out a
-1.
which leaves me with
X plus 1.
And sure enough, if I pull out,
X squared.
I'll also get,
X plus 1.
so I can go ahead and factor this by grouping, pull out the common,
X plus 1.
and that'll leave me with,
X squared -9.
but I'm going to factor that down to,
X plus 3, X -3.
and that's going to give me 3 critical points very quickly.
-3, -1, 0. Oh, I was going in order, sorry.
So -3, -1, and
3.
3. All right. I heard the 0, and that also threw me off. All right, so I was like, I thought he was going in order. Now I'm not sure what he's doing. All right, so 0 does exist. It's not a critical point, though. We've got the or equal to, so let's do solid dots at -1, solid dot at -3, and then a solid dot at +3 as well. My 3 ranges.
-infinity, -3. -3, -1. -1, 3. 3 infinity.
There we go. I'm eventually going to get a comma in there. And 3 to infinity. First value I will always want to test if I have it, class.
0.
0, which is going to fall in this range. And does 0 check out?
No.
No. Let's try a -2. That's going to give me here, Abby.
-8 plus 4 minus, no, it's negative, so +2.
And is that bigger than a 0?
Yeah.
Yes. All right. If I'm a gambling man and I'm running short on time, what's my other range that works, class?
3 to infinity.
The last one, the 3 to infinity. Because I'm going to gamble, it can't be inners, outers, right? Because I've already got a conflict in the inners. So it's got to be an alternating set. And that actually is how the answer turns out. And how many had those answers on 19? Questions on 19? Questions on 19? All right, let me give you some classwork. We will get back to the last part of your homework, but I want to kind of stay with these and give you just a couple more to work, and then we'll look at the rational inequalities that we introduced yesterday. So for now, find a new section in your notes, but be prepared to turn back to your homework in just a moment. At your seats, I want you to solve this inequality and this inequality. There's a hair stuck in my garland. It's a long blonde one, so hopefully that just means wife. Mason?
It's Maddie's.
Oh no. What's he been doing with your hair, Patty?
Oh, man.
This could go south quick, let's stop. questions on the first one? We got negative infinity to negative 8 in parentheses and 7 to infinity in parentheses. Any question? All right, continue on the second one. Again, if you're watching on YouTube and you have questions, email me, let me know if there's anything in here that's giving you a hard time. This is a little, has places where I can see this being confusing. So if you're struggling at all, as always, don't hesitate to reach out to me and I'll get you the help that you need. Did we get 1, 4, and negative 3 for the critical points? All good there? Questions getting those?
I copied it down wrong.
Oh, okay. I'm going to test my 0 first and get nothing is less than negative 12. That's a lie. I'm going to try 2, which is negative 14, and negative 4. That is correct. So I'm going to gamble. It's alternate, and there's my answer. How many had that answer? All right, so we see ways to really speed up our work with a little, not really gambling, because when you understand patterns, right, you understand how it's going to work. Now again, if your quiz or test, you got a little extra time, you're like, I want to be sure I get that sticker. It's been eluding me all semester. Then maybe you check, one more of those ranges just to be sure, but for sake of time, we'll leave it there. Questions on the quadratic or higher power inequalities? All right, let's take a look at the rest of your homework now, where you had numbers 1, 2, and 6 at the top of page 149. Begin looking at rational inequalities, and I said the first key, class, is to set the whole thing to 0, and then on the left-hand side, or right-hand side, I guess whichever side's not the 0, we needed the entire thing to be a single fraction. That worked out great for us here. Once it's a single fraction, I said set the numerator equal to 0, and then also set the denominator equal to 0. So my numerator critical point is a, and the denominator critical point is a positive 4. Now, why separate these out? Because numerator critical points, remember, will take on whatever this indicates. Open dot, closed dot, whatever it's supposed to be based on this. What's true of the denominator always, class? Always open dot. So even if we had the or equal to, okay, this would be a closed dot, but this would still be an open dot. So that's the reason to keep them separate. How many had negative 2 and 4 as your two separator points? So we should have had then everything from negative infinity to negative 2, negative 2 to 4, and 4 to infinity. As it happens, everything gets parentheses because there isn't an or equal to. And I'm going to try plugging the 0 right off. That doesn't work. I'm going to try plugging in a 5. That does. This should also work. Let's try like a negative 3, and that's also going to work. How many had this answer right here on number 1? All right, does anyone need more detailed explanation, or are we satisfied with that? All right, let's go to the next one, where, again, no closed dots anyway, so it takes away a little of the need. Numerator critical point, class? 2, denominator critical point, 5. Again, this is always an open circle. This happens to be an open circle also. Negative infinity to the 2, 2 to the 5, 5 to infinity, all parentheses. Plugging out a 0, that's giving me a positive, which is not less. And then plug in a 3, that produces a negative. Plug in a 6, that gives me a positive, which isn't less. So 2 to 5, good to go on number, whatever that was. Whatever number that was. 2. Number 2. We're going to go on number 2. Any questions on number 2? All right, let's take a look at number 6. This one was a little more, no it wasn't. I lied. This one wasn't involved either. Negative 9x positive 27 over x positive 6. Well, okay, there was one little difference, I guess. This is a little more obnoxious when set to 0, unless you just bring the negative 9x over class as a positive and then divide away the ticket x is equal to 3. So that's my numerator critical point. Denominator critical point class is simply negative 6. This is always open circle. This one class, this time has to be a closed dot. Okay, so when I set my 3 ranges, with or without the number line, right? Negative infinity to negative 6 keeps the parenthesis. Negative 6 to 3, parenthesis on the negative 6, put back to a bracket on the 3, and then bracket for the 3 to infinity. Here's where my 0's at. That's positive. That doesn't work. Try a 4. Goodness gracious, that's going to be negative divided by positive is negative, so this will check. And then try something like a negative 7. That'll make this positive divided by negative. This checks as well. And do we get this answer for number 6? Question 6. Do we need to see anything worked out or anything you say, I'm not quite clear how you did that or what you did different?
I wrote the negative 6, but then when I did that thing,
The testing?
I had 3 instead of negative 6, and then I swapped everything.
Gotcha. Okay. All right. Questions? All right. Let's go and do a couple more of these together. Number 11, go and copy it down. We'll spend the remainder of our time today making sure we're good to go on these as we kind of wrap our last pre-exam concept. Wrong thing. Let's try the book. Number 11. We have a negative 35 over x positive 12 is greater than x. Here, unlike the homework problems class, it is not yet set to 0. So what do we need to do, Genesis? Okay, by doing what? Move something to the other side, right? Now, normally, class, we would move the x over, wouldn't we? But if I do, it becomes negative. What if instead we move that over, which is, slide the negative out front, a negative. That way, when it moves, class, it becomes positive. Is that absolutely necessary to do? No, you could certainly do it the other way. But I'm always looking for ways to avoid negatives because they mess me up. I did also give you a strategy tip. I said put the x, if it's not a fraction, over 1. Because your next step is to get a common denominator so that you can combine this all into 1. So remember, draw a big long line. And what's going to go under the big long line, Michael?
X negative 12, or positive 12.
X positive 12. Now again, here, this already is an x positive 12. So I don't need to change anything about what is now a positive 35. But here, how do I turn a 1 into an x plus 12?
You multiply it.
And what we do to the bottom?
X squared positive 12x.
There we go, multitude to the top. And that ends up giving me an x squared positive 12x, positive 35. Any questions on how we did that for those first couple of steps? Again, this avoids all the negatives. Otherwise, if you're on the other side, everything's negative, isn't it? At this point, I'm ready to set numerator and denominator to 0. But unlike the homework problems, the numerator this time, class, is quadratic. Right, I've got the x squared. So here I'm actually going to get a couple of numerator separator points. Obviously, since it's quadratic, I'm going to need to class backwards FOIL. We could probably do that in our head. What are our factors?
7.
X plus 7 and x plus 5, right? So what are my numerator separator points?
Negative 7.
Negative 7 and negative 5. Do you run a risk doing that in your head that you accidentally just put 7 and 5 down? Yes, you do. But I'm really, really lazy. And so I just try to be careful mentally, but I don't have to write anything this way. And obviously my denominator separator point class will be negative 12. My denominator separator point is always going to get open dot. So in an interval, my separator point is always going to get parentheses. My numerator here is going to get parentheses as well, open dot or parentheses also. So everything's parentheses. 3 critical points, 4 ranges. What are my 4 ranges, Audrey, without drawing a number line?
Negative infinity, negative 12, parentheses, negative 12, negative 7, parentheses, negative 7, negative 5, parentheses, and negative 5, infinity, parentheses.
There we go. Again, as much as you can do in your head versus on paper, it just helps the math go faster. Again, that said, the more you don't do on paper, the less partial credit I can give you. But hey, we're going to get all the credit, so we don't need partial credit. I'm going to start here with the 0. And that ends up giving me negative 35 twelfths is greater than 0. Is that true, class?
No.
No. All right. Negative 6 is the only integer in that range because you can't use negative 7 or negative 5. And so if I plug in a negative 6 here, class, that makes this positive 6. So I get negative 35 sixths is greater than, and that becomes negative 6. Ooh, that's tight. What is this value in terms of maybe a mixed number or a decimal even?
5 and 3 6.
Negative 5 and 5 sixths. Is negative 5 and 5 sixths greater than negative 6?
Yes.
Ever so slightly. Again, you look at the number line, here's negative 6, here's negative 5, here's negative 4, right? Going negative 4, negative 5, negative 5 and a half, negative 5 and 5 sixths is a tiny bit bigger than negative 6. So